Hello everyone, welcome to this new video. In this video, I will be teaching you Docker from scratch. This will be complete Docker course for beginners. Whether you are a developer building an application or a tester running automation or a DevOps engineer deploying into cloud, Docker is everywhere. In this video, let's understand what is Docker, why Docker is needed, what is container, how Docker is different from virtual machines and Docker architecture. Before Docker, let's understand what are the real world pain points. Before Docker, you have to install the OS, language, Python or Java, libraries, etc. manually on every developer machine or server. And the next point is, if you test this application locally, but if it still fails in the stage of production because of different operating system version or missing dependencies. And the next is, deploying applications meant copying code, setting environmental variables, installing packages, often with errors and configuration mismatches. These virtual machines takes minutes to boot up and start the applications, which slow down the testing and development process. Docker solves all these problems by letting you package your entire application, including the code, runtime, dependencies, libraries, configurations into a single unit called container. This container can run on any system that Docker is installed, whether it's your laptop, test server or a cloud production server. Now let's discuss what is Docker. Docker is a containerization platform for packaging, deploying and running applications as containers. So what is containers? A container is a lightweight, standalone and portable unit that contains everything your application needs to run, including application code, dependencies and libraries, runtime, configuration files, environmental variables. This process is often called as Docker workflow. Docker build, Docker push, Docker run. You build your image and push it to Docker Hub or a private repository. Now that you have image, from that image you create and run a container. So now we have discussed how Docker creates container from image. Isn't this similar to virtual machines? Both seems to run application in isolated environment. So let's discuss how Docker containers are different from virtual machines. Now let's take a close look at how virtual machines work. We will break it down step by step, starting from hardware layer all the way to the applications. At the very bottom, we have a physical hardware. This is your laptop or a desktop or a server in data center. This includes your CPU, memory, disk, all the components that make up your machine. Above the hardware, we install a software called hypervisor. This is what allows us to create and manage virtual machines. This can be a VMware or Hyper-V. This hypervisor divides your physical machines into multiple isolated virtual environments. Each virtual machines that you create has its own guest operating system. This could be Ubuntu, Windows, Mac, CentOS or anything. It has its own kernel, system files, drivers and libraries. Finally, inside each virtual machine, you install your applications. For example, application A runs on VM1, application B runs on VM2 and application 3 runs on VM3. So as we saw in a virtual machine setup, each application needs its own guest operating system. It's powerful but not lightweight. But what if we could remove the extra OS layer and still run applications in isolation? That's where Docker container comes in. Just like VMs, Docker containers also run on top of your physical hardware. On top of that, we have host operating system. This is your main OS like Ubuntu, Windows or Mac. All Docker containers share the same OS kernel. This is one of the biggest differences from virtual machines. In VMs, each app needs its own operating system, which is heavy. But in Docker, all containers share the host operating system kernel, which makes container lightweight. Next, we install Docker engine on the host operating system. We can call it as Docker daemon. This is the one which actually run and manage your containers. So with Docker, you can spin up a container in seconds with just the app and its dependencies, unlike a VM which needs to boot an entire operating system. Here I have compared virtual machines versus Docker. Virtual machines utilizes full OS, whereas Docker shares the host operating system kernel. Virtual machines are gigabytes in size and Docker containers are lightweight, megabytes. Due to this size, virtual machines takes minutes to boot up and Docker containers take seconds. And Docker containers are less portable. So now we understand how Docker is lightweight and share the host operating system. The next question is, how does Docker actually work under the hood? Let's take a look at Docker architecture. Docker follow client-server architecture. That means client sends requests and server processes and sends responses. Let's break down three main parts of the Docker architecture. Docker client, Docker CLI. This is what you interact with. You open your terminal and type commands like docker run, docker build, docker pull. These commands go to the Docker client, which then forwards the request to the Docker server. Then Docker daemon. This is the actual server that runs in the background. It listens to the commands from the client and does the heavy lifting, like building images, running containers, and managing networks and volumes. We often call it as Docker daemon. So whenever you type a Docker command, it goes through the client and then REST API and then daemon. Let's say you have created a simple application Hello World. Here is how Docker would handle it. You write a Docker file, which is a text file that tells Docker how to build an application. You run docker build. This creates an image from the Docker file. You run docker run. This launches a container based on that image. The container is a live running instance of your app. Now run docker push to upload it to a registry like Docker Hub. Others can use docker full to download and run your container on this system. All of this managed by a Docker daemon behind scenes. Let's discuss one more component, Docker registry. Docker Hub is the default registry. You can also use AWS Elastic Container Registry. Let's summarize Docker architecture quickly. Client, where you type commands. Docker daemon, the background process that runs everything. REST API, connects client and daemon. Images and containers, how your app is packaged and run. Registry, to share and download container images. These systems make Docker lightweight, fast, and perfect for DevOps and microservices. In the next video, we will move from architecture to action. We will learn how to create Docker images, run containers, and do some hands-on exercises to reinforce everything what we have covered so far. Thanks for watching. If you found this video useful, like it, share it, and don't forget to subscribe my channel.